Welcome students to our V4U Chemistry channel. Here you will find the unsolved numericals of K.L. Kapoor Vol 1. Today video content is how to calculate the pH of a amphiprotic ion, weak base and amphiprotic acid and hydrolysis of a metal ion. In the above question, given concentration of sodium dihydrogen arsenate is 0.1 molar. Dissociation constant of arsenic acid of first step is 4.9 multiply by 10 raised to power minus 3, second dissociation step is 5.6 multiply by 10 raised to power minus 8. Third dissociation constant is 3 multiply by 10 raised to power minus 12. Arsenic acid dissociates in 3 steps. First dissociation step is arsenic acid into dihydrogen arsenate and hydrogen ion. Dihydrogen arsenate dissociates into hydrogen arsenate and hydrogen ion. Hydrogen arsenate dissociates into arsenate and hydrogen ion. As we see, dihydrogen arsenate is an amphiprotic ion. Amphiprotic ion is an ion which can accept or lose proton. pH of an amphiprotic ion can be calculated using half sum of pKa1 and pKa2. On putting Ka1 and Ka2 value, we get pH value equal to 4.78. Answer: pH of sodium dihydrogen arsenate is 4.78. In the above question, given is the concentration of sodium arsenate is 0.1 molar. Dissociation constant of arsenic acid of first step is 5.6 multiply by 10 raised to power minus 3. Second dissociation step is 1.7 multiply by 10 raised to power minus 7. Third dissociation constant is 3 multiply by 10 raised to power minus 12. Arsenic acid dissociates in 3 steps. First hydrolysis step is hydrolysis of arsenate into hydrogen arsenate and hydroxide ion. Hydrogen arsenate hydrolysis into dihydrogen arsenate and hydroxide ion. Dihydrogen arsenate hydrolysis into arsenic acid and hydroxide ion. As we see, dissociation constant of first and second step is much less than first hydrolysis constant of first and second reaction. So reaction goes forward. But third reaction hydrolysis constant is less than dissociation constant of third step. So pH can be calculated using half sum of pKa2 and pKa3. By putting the value of Ka2 and Ka3, we get the pH value equal to 9.39. pH of sodium arsenate is 9.39. In the above question, given is the concentration of potassium sulfide is 0.8 molar. Dissociation constant of hydrogen sulfide of first step is 1 multiply by 10 raised to power minus 7. Second dissociation step is 1.3 multiply by 10 raised to power minus 14. Dihydrogen sulfide dissociates in 2 steps. First dissociation step is dihydrogen sulfide into hydrogen sulfide and hydrogen ion. Hydrogen sulfide dissociates into sulfide and hydrogen ion. As we see, dissociation constant of first step is much greater than second dissociation constant. It implies that degree of hydrolysis of second step is much greater than second degree of dissociation. So reaction go forward. Degree of hydrolysis of first step is less than first degree of dissociation. So degree of hydrolysis can be calculated using second step. Hydrolysis dissociation constant is equal to product of concentration of potassium hydrogen sulfide and hydroxide ion divided by potassium sulfide. KH is equal to concentration of potassium sulfide multiplied by square of degree of hydrolysis divided by 1 minus degree of hydrolysis. By putting the value of KH, which is equal to Kw divided by Ka2 and concentration of potassium sulfide, we get a quadratic equation in degree of hydrolysis. On solving, degree of hydrolysis is equal to 0.611. Answer of the question is percent degree of hydrolysis is equal to 61.1%. In the above question, given is the concentration of sodium bicarbonate is 0.1 molar, bicarbonate is an amphiprotic ion. pH of an amphiprotic ion is equal to half sum of pKa1 and pKa2. By putting the value of Ka1 4.2 multiply by 10 raised to power minus 7 and Ka2 4.8 multiply by 10 raised to power minus 11, pH value equal to 8.35. Answer: pH of part A is 8.35. In the above question, given is the concentration of ammonium bicarbonate is 0.1 molar, bicarbonate is an amphiprotic ion and ammonium ion is a weak base. Hydrogen ion concentration of an amphiprotic acid and weak base is equal to square root of Ka1 multiplied by Kw divided by Kb minus Ka2. By putting the value of Ka1 4.2 multiply by 10 raised to power minus 7. Ka2 4.8 multiply by 10 raised to power minus 11 and Kb 4.8 multiply by 10 raised to power minus 11, pH is equal to minus log of hydrogen ion concentration of an amphiprotic acid and weak base. On solving, pH is equal to 7.84. Answer: pH of a weak base and amphiprotic acid ammonium bicarbonate is equal to 7.84. In the above question, first part given concentration of copper sulfate is 0.1 molar. Hydrolysis constant of copper ion is 1 multiplied by 10 raised to power minus 8. Hydrogen ion concentration of a hydrolysis of a metal ion is equal to square root of concentration multiplied by hydrolysis constant. pH of a hydrolysis of a metal ion is equal to minus log of hydrogen ion concentration. By putting the value of C and Kh, we get the value of pH equal to 4.5. Second part, given concentration of iron nitrate is 0.05 molar. Hydrolysis constant of iron ion is 5 multiplied by 10 raised to power minus 9. Hydrogen ion concentration of a hydrolysis of a metal ion is equal to square root of concentration multiplied by hydrolysis constant. pH of a hydrolysis of a metal ion is equal to minus log of hydrogen ion concentration. By putting the value of C and Kh, we get the value of pH equal to 4.80. Don't forget, like, share, and subscribe, and we'll see you in the next video. That's right. If you have any questions, whether it's related to the topic of this video or any other academic subject, drop them in the comments, and we will be more than happy to help you out.